download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support, and so much more. This video is about atom economy. Now, atom economy tells you the percentage of reactants that form useful product. If something has 100% atom economy, it tells you that all of the reactants turn into desired or useful products. The higher the atom economy, the more green the reaction. So for example, say we again have a reaction that's A plus B gives C plus D. Now let's say that in this reaction, C is useful and D is waste. So for example, let's say D is carbon dioxide, it's a waste product and we don't want it. The atom economy of this reaction will tell you the percentage of C that's formed compared to obviously the overall. So how much of this reaction has produced C compared to the total mass made. And we'll look at the reaction in a second. Now it's important to understand that if a reaction only has one product, then the atom economy must be 100%. So if we had A plus B produces C, C is the only product, and therefore it is the useful one, it's the desired one, and therefore 100% of the products are useful, so it has an atom economy of 100%. Now the equation to calculate atom economy is equal to the relative mass of useful product divided by the relative mass of all the reactants times by 100. And that's how we calculate the atom economy. So let's go through a worked example then. So we can extract pure copper from copper oxide using carbon. The equation is shown below. What is the atom economy for this reaction? Well, what do we want? Well, we want pure copper. So that's what we want. This is the useful compound that's formed, or element in this case, and this is the waste product. So here we have the useful product and here we have the waste product. And we want to calculate what is the atom economy. So as we know, atom economy is equal to the relative mass of the useful product divided by the relative mass of the reactants, which obviously are here, times by 100. So the first thing we need to do then is we need to work out the relative mass of our useful product. So what is useful here? Well, it's copper. And we've got 2 Cu, we've got 2 copper, so 2 Cu. If we were to go and look on our periodic table, we'd know, of course, that copper looks like this, 63.5 Cu and 29. So that is copper. Therefore, we know that the mass of one copper is 63.5, but we have 2 coppers, so we're going to do 63.5 times by 2, which gives us 127. So we know the mass, the relative mass of our useful product of copper is 127. Now we need to find the relative mass of the reactants. So reactants, we've got 2 CuO plus carbon. So 2 Cu, so Cu as we know looks like this on the periodic table. Oxygen O is like this. And then carbon, if we were to look up carbon, it would look like this here. So let's do this here. So we've got Cu, which is 63.5, plus oxygen, which the mass is 16. But we've got 2 of them, so we're going to times that by 2. When we put that into our calculator, 63 plus 16 times by 2, we get 159. So the relative atomic mass of copper oxide, or 2 of copper oxide, is 159. And we also need it for carbon. Well, carbon is just 1 carbon, so it's 12. Therefore, to find out the total relative mass of the reactants, we need to do 159, which is here, plus 12, which we've got for carbon. So 159 plus 12 gives us 171. So what that tells us is the relative mass of all our reactants is 171. So we can now put these into our equation. The relative mass of the useful, which is 127, divided by the relative mass of the reactants, which is 171, times by 100, gives us an atom economy of 74.4%. And that's how we work out the atom economy. Okay, so remember, we need the relative mass of the useful, so we need the periodic table for that, the relative mass of the reactants, and then times that by 100. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers, and so much more. The link is in the description. So here are some summary questions. Pause the video to have a go. Okay, so why is it important to maximise atom economy? Well, it makes for a greener reaction and therefore less waste product. Well, what do we actually mean when we're talking about atom economy? Well, a good definition is the percentage of reactants that form a useful product. Okay, so percentage of reactant that form useful products. What is the equation to calculate atom economy? Well, I write it up here. Atom economy is equal to the relative mass of the useful product divided by relative mass of reactants times by 100. State one advantage of a high atom economy. Well, of course, less waste. So it is a greener reaction. And then titanium can be extracted by titanium chloride. Calculate the atom economy. So we want titanium, so that is the useful product. So we need to find out the relative mass of that, which is 48. So titanium is a relative mass of 48. That's our useful relative mass. And then we need to find out the relative mass of the reactant. So titanium chloride, which is Ti, Cl4. Now Ti we've just said was 48, and we need to add that to Cl4, which is 4 times 35.5. And when we do, so 48 plus 4 times 35.5, and for that you would have got 190. So we've worked out the relative mass of that. And then we need to work out the relative mass of magnesium, and that's up here, that's 24. So we only have one magnesium, as you can see. So we need to do 190 plus 24, which gives you 214. So that's the total relative mass of the reactants. We then can do the useful, which is 48, divided by the total, which is 214, times by 100, and you should have got an atom economy of 22.4% for your answer. So we've now looked at a video on atom economy. There are plenty of practice questions on the website, and as ever, if there's anything you didn't understand, get in contact with a tutor who will happily help.